Why, hello. How you doing? We are going to start going over the August 2016 Algebra 2 Common Core, or Regents, if you will, examination. Now, we've already done the June 2016 exam, so this is our second exam that we're going to be going over. All right? It will take about 5 videos to cover this whole exam because I like to do somewhere around 8 questions or so per video. And I like to keep them anywhere from 30 minutes. Sometimes these ones go a little bit longer, maybe to 40-ish, because sometimes there's alternate ways to do things. I don't always show every single way to do things, but I like to show maybe some of the better ways to do things. All right. You'll also notice we have these things right here. This is just a breakdown of my own personal observation for this test, okay? You'll notice that 17 of these problems, not problem number 17, but there are 17 problems that are really just heavy algebra. There's 7 problems that I categorize as data or stats, 8 problems that are trig or exponentials, and there are 5 that are kind of just like miscellaneous, like maybe they deal with sequences, or they deal with maybe end behavior of graphs, things that I wouldn't categorize in the first 3 things. So as we move forward, you'll see problem number 1 here. It's highlighted in orange. That tells me that I categorized it as one of the 17 algebra problems. That's all that means. That's what I do to my class. And I've noticed that most tests, not all of them, occasionally get one that's slightly different, but most of these Regents exams have roughly, I don't know, 17, like maybe 15 to 19 algebra problems. Most exams have anywhere from, like, I don't know, 5 to 9 data or stats problems, and 5 to 9 maybe trig or exponential, and I don't know, 4 to 6 miscellaneous problems. Those are kind of a good ballpark for what you're going to see, all right? So, without any further time wasting, because we are already 2 minutes in, let's advance. Now, always got to read the directions. Answer all 24 questions in this part. This is part 1. This is multiple choice, okay? Each correct answer will receive 2 credits. And I tell you, I say this every time, kids, I love multiple choice. I do not love it. I like it. I do not love it. Simply because no partial credit will be allowed, okay? Any short answer problem there is, you can always receive partial credit. For multiple choice, you can be 98% correct. And if you make one minor detail or circle the wrong answer just because you're not paying attention, you get nothing. You get nothing. I love that line from Willy Wonka, the Chocolate Factory. The one with Gene Wilder, not Johnny Depp. Sorry, all you young kids. Anyways, let's move forward. All right. Number 1. Which equation has 1 minus I as a solution? Okay. First off, if there is any way you can use a calculator on any of these problems, I will let you know. But more times than not, I'm going to show you the algebraic way to do it, because if you're in a situation where this is a short answer problem, you need to know how to do it algebraically. All right. But I will tell you, you can do this one in the calculator. What do I mean? I can take 1 minus I, okay, and I could set that's my x value. They're saying which is a solution. So which one of these equations, 1, 2, 3, or 4, can I put 1 minus I in for this x and this x, and will it equal 0? If it does, then 2 would be your answer. I could take 1 minus I and put it in for this x and this x and see if it'll equal 0. If it does, 1 is your answer. So you can go through and you can actually plug in 1 minus I for all these x's and see which one equals 0. Now, I'm going to do this algebraically. And sometimes doing things algebraically sucks because you're going to have to do things algebraically to all 4 answers to see which one is correct. All right? You need to use the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. This is on your reference sheet. That's on your reference sheet right there, okay? You should know it by now, okay? You've been using this for 3 years already, maybe more. I'm going to tell you right now the answer is 4, all right? So I'm going to use my quadratic formula for choice 4 here, all right? A is 1 because it's 1x squared. B is -2. You need to take the sign with it. And C is +2. All right, now you absolutely need to include the signs. All right, do not take the X's. Okay, so A is 1, B is -2, and C is +2. Okay, so let's just start plugging them in here and simplifying. Okay, I negate my B value, which is already -2, plus or minus the square root of my B value, -2 squared, minus 4 times A, which is 1, times C, which is 2, all over 2 times A, which is 1. All right, so let's simplify it. Okay, when I negate a negative, well, that just means +2, plus or minus. All right, what I like to do is forget about the radical. All this stuff under here, I like to figure out what that is. If I take -2 squared, that gives me 4, okay? And 4 times 2 times 1 is 8. So 4 minus 8 would be -4 is underneath this radical, all over 2 times 1 is 2. Okay, let's clean this up. We're almost done. 2 plus or minus. You need to remember that a negative pops out and becomes an I. So technically, the square root of -4 is I radical 4. Okay, and the square root of 4 is 2. So that's really 2I. Okay, so this thing right here is going to simplify to 2I, all over 2. The bottom hasn't changed. Now at this point, you should say, well, 2 goes into every one of these terms. 2 goes into here once, 2 goes into here once, 2 goes into here once. So I really have 1 plus or minus 1I over 1. But, you know, we really don't have to write over 1. Okay? So this tells me I have two answers. 1 plus I and 1 minus I. They're asking you which equation has this as a solution. Okay, and it's right there. So it's choice 4. Now, I told you can do this in the calculator, and I'm going to show you briefly how you can do just that. All right? Now, I'm not going to do this for every single problem, but this is a quick one here. Turn this on. All right, I'm going to take 1 minus I, and I'm going to put it in for these x's. Yes, the I is actually in the calculator. So instead of x squared, I'm going to put 1 minus I squared. Parenthesis, 1 minus, above the decimal in blue is I. Squared, okay? Minus 2x, so minus 2. And again, I'm going to put in 1 minus I. Okay? And then I have plus 2. And since we know this is the answer, it should equal 0. 0 it is. So you can do that in a calculator. Number 2, that was highlighted blue, so this is a data and stats problem. But you know what? You have to do no math. I wish you got 4 or 5 problems just like this, okay? This is a common sense one. All right, let's take a look here. It says which statement or statements about statistical studies is true. All right, so first of all, I'm not circling these Roman numerals. These are the 4 statements. These are my choices for anything that's right or wrong, okay? So 1 says, a survey of all English classes in high school would be a good sample to determine the number of hours students throughout the school spend studying. I like that one. That's a good one. Why is that good? Because they're asking all English classes. You're not going to English and then to math, where you might have some of the same students that were in your English class. You go later to math, maybe they're the same. If you just stay in your English class, you're going to see all the kids filter in and out of that classroom. And they're asking students about the number of hours that students spend studying. So I like that. That's a good one. Okay. Number 2, a survey of all 9th graders in a high school would be a good sample to determine the number of parking spaces. No. 9th graders have nothing to do with parking spaces. No, no. 3, a survey of all students in one lunch period in a high school would be a good sample to determine the number of hours adults spend on social media. No, I'm not going to ask students about what adults do. That's bad. I mean, if someone asked my kid what I did online, first I'd have to go clear my history in my browser. I'm just kidding. I'm joking. But no, in all seriousness, no. Stop it. That's not a good study at all. So number 4. The survey of all calculus students in high school would be a good example to determine the number of students throughout the school who don't like math. All right. You might say to yourself, well, I mean, students who like, either they like or don't like math, to me, this shows bias. What does that mean? If I ask kids in calculus whether they like math or not, chances are kids in calculus like math, okay? That's why they're in calculus. Not only do they like math, but they're good at it. Yes, there are some kids that don't really like math too much. They'll tell me, I don't love it, but I don't hate it. I'm just good at it. That's why I'm here. And that's fine, but that shows bias, okay? So I'm going to put a red X through here because if this was for the test, maybe you'd say, I don't know about that one. One is definitely good. So let's look at our choices here. I know my answer should have number 1 in it, okay? Here has 1. Here has 1. The others, choice 2 and 4, do not, okay? So does either 1 or 3 also include 4? No. I have 1 only and 1 and 3. We know 3 is definitely not. So the answer is only 1. I love me some calculator, people. All right, and number 3 is straight out of the calculator. All right, straight out of the digital world. To the nearest tenth, the value of x satisfies, or which value of x, okay, I guess, would satisfy 2 raised to the x equals negative 2x plus 11. Okay, now one of these is the answer. You could do this algebraically. It would be a little bit of work, but since we have a calculator, let's just go right to it, okay? How do I figure out the answer, okay, for a variable? If I have 2 things equal to each other, I graph them both. And the answer is always where the 2 graphs intersect. So let's go to y equals. I'm going to put 2 to the x, 2 to the power of x. That is in my first one. And for y2, okay, I'm going to put this side. Yep, that's me right there. I'm going to put, okay, negative 2x. Don't put minus 2x. It's a negative plus 11. All right. And if I graph this, there we go. There's 2 to the x. And there's negative 2x to the other right there. Now, I know for a fact my answer is where they intersect here. So if I want the intersection point, okay, I go second, trace, because it says calc. I want the calculator to actually calculate the intersection, which is choice 5. So I can scroll down or I could just press 5. And see this little bug dude? I call him a little bug. Looks like a little bug crawling. All I got to do is put him closest to whatever intersection. He could be here, here, here. You don't have to be right on it. You just have to be closest. So if they happen to intersect at 2 points, how do you know which one you're going to get? You just move this little bug dude closest to whatever one you want. And you hit enter 3 times. 1, 2, 3. And look what they do here. Look what they do here. They're so tricky. Okay, first of all, you might say to yourself, well, I see 2.5. So the answer is 2.5. No, it is not. To the nearest tenth, I got to round. This 5 should round up to a 6 because the number after it is 5 or bigger, 2.6. Well, some of you might say, oh, well, look, there's 5.8 here, so it's this one. No. First of all, if it's rounding, that would go to a 9 because the number after is 5 or bigger. We're solving for x. I don't want 5.9. That's the y. You see what they do here? They try and screw with you. Your answer is your rounded x value, which is 2.6. Very good. Very good. Very good. Number 4. The lifespan of a 60-watt light bulb produced by a company is normally distributed. Oh, I love when I see that. That tells me data, stats, bell curve, and chances are I might even get to use a calculator again. Okay, so it's normally distributed with a mean of 1,450 hours, okay, and a standard deviation of 8.5 hours. Okay, I know those are important too. All right. If a 60-watt light bulb produced by this company is selected at random, what is the probability that its lifespan will be between 1440 and 1465? This just screams lower and upper limit to me, okay? And if I have my lower and upper limit, and I also have my mean and my standard deviation, I can absolutely use a calculator, okay? I should even... There's a part in the calculator, normal CDF. Normal CDF. Okay, it's under the distribution menu, and I will show this to you in a second. And it literally has these four things. Okay, my lower is 1440, the bound. The upper bound is 1465. This little smushed M here, it means mean. And this O with a pigtail on top here means standard deviation. You literally put it in the calculator and hit enter, okay? So I got my calculator up here, and I told you it's in the distribution menu. Above VARs, in blue, it says distribution. It's actually the abbreviation for it. Second, distribution. I do not want normal PDF. I want normal CDF, choice 2. Oh, look at that. Let's get out of here first. Ha, ha, ha. Choice 2. Bang. There it is. But this number's here. You know what? Just hit clear. Okay? And let's put in our information. I mean, it is exactly like I said it would be, except the word paste, which we're going to use at the end. So from 1440 is my lower bound to 1465 is my upper bound. My average or my mean is 1450. And my standard deviation is 8.5. Once I hit paste, it puts it in the normal CDF function, and I just hit enter one more time. Boom. So my average probability, and if you look, all of these probabilities, these answers are 4 decimal places. So if I go 4 decimal places, I get 8414. That 4 will round up to a 5 because the number after it is 5 or bigger. Bam. Just testing you on whether you need to, you know how to use a calculator or not. It's beautiful. Normal CDF. Number 5, another algebra problem. Which factorization is incorrect? I don't know about you, but my students, when they see an italicized word, you think they would spend more time absorbing it. They don't. It's like they don't even see it. It's like italics is some sort of font where we try and hide the word. Because 3 of these are going to be correct. 1 is not going to be correct. Okay? So if I look at the first one, I'm like, oh, yay, that's right. 4k squared minus 49 does equal 2k plus 7 times 2k minus 7. And they circle that, but there's 3 of them that are right. 1 is wrong, okay? So you can do part of this in the calculator, but not all of it. What do I mean? Whenever we have 2 things, and we're going to look at number 1 here, okay? We're looking at number 1. Whenever I have 2 things set equal to each other, as long as there's only 1 variable, see how there's a k and a k and a k? There's 1 variable. What I can do is I can put this side into y1 in the graph, okay, and I can put this side into y2 just like it is. Don't even change anything, okay? You might have to make the k's x's. And if the graphs are the same, then those expressions are the same, and they are equal. If the graphs are not the same, then those expressions are not the same, and they won't be equal, okay? So if I put 4k squared minus 49 into y1, and I put 2k plus 7 times 2k minus 7 into y2 and graphed it, they would be the exact same graph because that is a true statement. They are equal, okay? Now, I said you could do most of this in the calculator. I cannot do number 2 in the calculator. How come? Because there is not just 1 variable. You have an A, but you also have a B. And our calculator cannot put 2 different variables into y1. Okay, so you can't do that. I could use number 3 and number 4. I could definitely put those in the calculator, and maybe one of those will be the incorrect answer. So if that's the case, I can use a calculator to solve the problem, but I cannot use a calculator to check all 4 answers. The answer to this happens to be, okay, choice 3. If I put this into y1 and I put this into y2 and graph them, those graphs will not be the same. I'm going to show you how to do this algebraically, though. There's 2 methods. I can take the left side, okay? I can take the left side and factor it, this left side here, and see if it equals the right side. Or I could take the right side and expand it out and FOIL it and see if it equals the left. I'm going to FOIL the right side because we do a lot of factoring, and I think we should practice some FOILing as well. So if I have m minus 2 squared, that's like m minus 2 times m minus 2. And then I still have to multiply that times m plus 3. If I FOIL this, I should get m squared minus 4m plus 4. I still have to multiply that times m plus 3. Okay, so let's do that. I want to distribute my m first. I get m cubed minus 4m squared plus 4m. Now I'm going to distribute the positive 3 to these three terms. Okay, so I've got plus 3m squared minus 12m plus 12. If I combine these, I got m cubed. This should be minus m squared. This would end up with minus 8m plus 12. Is this the same thing as this? It is not, okay, because I have minus 8m here, but I have minus 4m here. I have minus m squared. This is plus 3m squared. So it's not right, okay? So choice 3 is definitely the answer. Now, fortunate for you, if you knew the trick about putting one of the graphs into y1, okay, and then going to the right side here and putting that in y2 and graphing it, that would actually show you that the graphs are not the same. So you could have done this without doing all this algebraic work. But if the correct answer would have been number 2, you wouldn't have been able to do it. Okay, unless for some odd reason you figured out that 1, 3, and 4 are not the right answer. But that gets kind of a little iffy. You should know how to do some basic algebra here. I mean, come on, it is the Algebra 2 exam. All right, another calculator problem. This one is straight in a calculator. It's going to be beautiful. Number 6 says, Sally's high school is planning their spring musical. Okay, the revenue, which is R, it generated can be determined by the function R of t equals negative 33t squared plus 360t, where t represents the price of a ticket. Okay, so t represents the price of a ticket. That's important. The production cost C of the musical is represented by the function C of t. That's 700 plus t. Okay, so t, the price of a ticket, is in both the revenue equation, which is R, and the cost equation, which is C. So the question is, what is the highest ticket price to the nearest dollar they can charge in order to not lose money? If I want to not lose money, that means I want to break even. That means if my cost is the same thing as much as my revenue, revenue is the money I make, cost is the money I spend. If they're the same, I break even. I don't lose money. If cost is more, okay, if I spend more than I make, then I lose money, okay? So I want to see where these two things are equal. I'm going to give you a little forecasting right now. I'm going to graph these two. Again, if I have two equations and I want to see where they're equal, I graph them and I see where they intersect, all right? Now, I know for a fact that t squared tells me it's a parabola, and the fact that it's negative means it's going to open downward. So this graph might look like this, R. Okay, this is R of t. I know that C of t starts at 700 and it has a slope of 5, a positive 5. I don't know, so maybe it goes like this. That's C of t. These aren't exact. I'm just drawing them right now. And I know that t is the variable that's in both of them. So technically my x-axis is going to be t, which is the ticket price. So there, I'm going to break even here and here. I want to know what's the highest ticket price, okay, that I can have to break even. So if I go here on the t-axis and I go here on the t-axis, which one would be a bigger value on t? This one would be, okay? So remember, let's say this is 1, 2, 3, 4, 5, 6, and so forth. This number is bigger than this number. So when I look to see where they're equal out of the two spots, which t, or in our calculator, that's going to be the x-axis, is bigger at the intersection points. All right, so that's exactly what we're going to do. Let's graph this. Turn this on. Turn this on. Do. On. I'm going to clear out our other problem. And let's put this here. Negative 33x squared plus 36dx. Boom. Clear this one out. 700 plus 5t, and in this case, in the calculator, I'm going to call that x. Okay, you're going to notice something when I graph this. You see this window is 10 by 10? See these little lines? It's thinking. It's like it's trying to graph it, They stopped. You know what that means? They've graphed them both already. Now, I'm going to show you a little trick here, kids. I'm going to do zoom, and under zoom, there's an option. You'll see zoom box, which I love, zoom in, zoom out. But you'll notice there's something that says zoom fit if I go down to 0. When you say fit, what the calculator does is it tries to get all of the important characteristics. Meaning, I've graphed two things here. Chances are, if I want it to fit everything that I graphed, it's going to get my maximum point here, okay, for my parabola. It'll probably get the zeros where it crosses. And it's probably going to try and include both points of intersection, okay? So remember, if I just go to graph, this is what I have. Now if I go to zoom, fit, which is 0, and I hit enter, it's changing. Bam. There's my parabola. There's my maximum. Okay, those are both my, it's 1 to 0, and then, boom, it crosses two spots. This is the intersection point I want, the one that's further down on the x-axis. This will give me an x value, but it will be smaller than this one. Remember, the problem saying which is the higher value for me to break even. Okay, so, you know, I'm going to adjust this. Right now, I want to try and adjust this. I want to go a little bit higher on the y-axis. It's going to go a little bit higher. And I don't need any of this. This, I don't know, this might go to minus 1,000. I don't even think I need below the x-axis. I certainly don't need anything left here. Using the screen the way it's up is fine. But I'm going to change it a little. I'm going to say, okay, I don't need any negatives in the x. Okay. Look at my y minimum, negative 6,900. I'm just going to call that 0. Okay. My maximum goes to almost 1,000. Let's just call it 1,500 just to see more room up there. If I graph that, okay, see, oh, pretty. Boom. Okay, perfect. I want this point. So I'm going to go second, calc, which is above trace. And I want the intersection again, 5. We were just talking about, if I'm closer to this point and hit enter 3 times, 1, 2, 3, see how the little x goes right here? That's 2.60. I can charge $2.60 and break even. But I want the higher x value, so I'm going to try this one as well. Second, calc, intersect. I got to do it again. And this time, I move my little buggy dude close. So whatever I'm closest to, okay, right now, if I stopped here, I'm closer. I like to get kind of just close. I don't have to be right on it. If I enter 3 times, it's going to check this one. 1, 2, 3. 8.15. That's definitely bigger than 2.60, okay? Now, they wanted it to the nearest dollar, right? That tells me $8 all day long. But the other one, 2.6, was closer to 3. So make sure you understand what's the highest ticket price. They can charge $8, and they can still break even because your cost will be the same as your revenue, okay? So my answer to the nearest dollar is $8. Number 7, data, stats. You know what? I love this problem. We did this in Unit 5, and it has to do with conditional probability, okay? The set of data in the table below shows the results of a survey on the number of messages that people of different ages text on their cell phone each month, okay? I know some of you are probably like, man, per month I'm sending like 1,300 text messages because you guys are savages on your phones. Anyways, okay, we have this table. Here, this represents the text messages per month. 0 to 10 messages per month, 11 to 50 messages per month, or over 50 messages per month. And this represents my age groups, okay? This is the 15 to 18-year-old group, the 19 to 22 age group, and the 23 to 60 age group. Wow, that's a big gap there. Anyways, if a person from this survey is selected at random, what is the probability the person texts over 50 messages per month given? Oh my God, whenever they say given in a table like this, it is easy. Okay, so what is the probability that a person texts over 50 messages per month given that the person is between the ages of 23 and 60? Now, I don't know how many people they interviewed all together here until I add all these numbers up. If I add them all up, that would give me my overall total. But you know what? I don't care about that right now. Do you want to know why? Anytime they use this word, oh no, my God, I've underlined it, circled, whatever, given, they give you, okay, given that the person is between 23 and 60, if that's what's given, that's what you have to pick from, okay? Here's my age group that's 23 to 60. I am given this age group to pick from, okay? So the probability that you have over 50, so more than 50, given, that straight line means given the 23 to 60 age group, okay? You are only given this to pick from. This I just circled. I mean, I can't stress it enough. You are only given these numbers to pick from. All this other poo-poo doesn't matter anymore. The thing is, I need to add all these up. If I add 157 to 47 and 25, I should get 19, carry the 1, 10, carry the 1, 10, 12, carry the 1. So 229. So out of the 229 that I'm given, how many, like this is my over 50 now. Okay, my over 50 is right here. Out of those three columns, the 25 people here, these send 0 to 10. These 11 to 50. These ones send over 50, which is what we're looking for, 157 out of my 229 that I am given to pick from. Oh my God, I can't explain it any simpler. 157 out of 229, given, conditional probability. Oh, it's a walk in the park. You just got to understand it. And I've said the word given so many times that I hope I drilled that into your mind. Okay, whatever you're given to choose from does not represent the whole survey anymore. Okay, we were given 23 to 60-year-olds, and there were 229 of them. So out of that 229, 157 send over 50 per month. Phew, it was exhausting explaining that so many times. All right, this is one of those, number 8, miscellaneous ones. It deals with sequences, all right? If you're a guesser, you're like, oh, Visca, I don't know this guy. First of all, calm down. Just take a breath. This is easy. I'm going to show you how you can, instead of getting a 1 out of 4 chance, because there are four choices here, instead of going 1 out of 4, which is a 25% chance of getting this right, I'm going to start making it a 1 out of 2 chance right here, 50% of this one right. Because recursive, okay, a recursive formula for this sequence they give you is what? In order for something to be recursive formula, they need a first term. It has to be given, okay? You see example 1, they give you the first term, G1 is 18, and then you use this to find all the other terms in a row. Like you find G2, G3. See number 2, how it doesn't give you a G1? If it doesn't give you a G1, this is not recursive. By definition, that's not recursive, so it's not 2. Let's look at number 3. Okay, they give me a G1, so that's a recursive formula. Look at number 4. Do they give me a G1? No, they don't. So right now, boom, 2 answers. Don't even look at these. Bang, bang. You know what? Let's get crazy. Let's get crazy. Let's do this proper now. As the British would say, let's do it proper. Okay, a little box. I'm going to take this. I'm going to do this. That's a square. That's a rectangle. I'm going to do. And let's make it green, my favorite color. No, that's a good one. Oh, recent colors. That's a fill color. I got to highlight it first. Bam. Now I pick a fill color. Ooh, green. Bam. Don't even look at them. We just have 1 and 3 to pick from now. Okay? You have a 50-50 shot. I like those odds. Now, let's take a look at this, okay? My sequence they give me. 18 is the first element, G1. Then it goes to 9. That's considered G2. G3 is 4.5, and so forth. All right? Okay, so both of them give you 18 as your first. Oh, that's a good. So let's look at what they do here, okay? You see this expression? Whenever they say G, they're having to use G. Maybe they use N, maybe they use V, maybe whatever. But that N minus 1, okay? So if I wanted to find, let's say, G2, let's say my N was a 2 here. I would take 1/2 and multiply it by G. I'd also have to put a 2 here. So 2 minus 1. What is 2 minus 1? 1. So really, I take the previous, if I'm finding G2, I take the previous term and multiply it by 1/2. So if I'm finding G2, I take the previous term and I multiply it by 1/2. What's half of 18? It is indeed 9. Okay, let's find G3. If I want to find G3, I take the previous term and I multiply it by 1/2. What's half of 9? 4.5. So this is the right one, and that is the answer. Let's take a look at number 3. How come number 3 is not the right answer? This is telling me if I want to find G2, I take 2 and multiply it by the previous one, G1. Okay, so if I had 18 here and I multiplied it by 2, I would not get 9. I would get 36. I'm doubling it, right? If I started with 18, I'm going to double it to 36. The next one, I double 36 to go to 72. The next one, I double 72 to get to 144 and so forth. So this is definitely not the answer. Okay, I'm hoping that if you saw this, you realize they are just shrinking by half. I'm hoping you knew that 1/2 was a tau. Right? And there you go. We're done with problems 1 through 8. You got this. It's not that bad. There are going to be some problems that suck, that either take a lot of writing, like of numbers and equations, or there's some that are going to throw you a curveball. That's to be expected. That's why there's a curve on the score adjustment afterward. But these aren't bad. Okay? You just got to know the math. If you know the math and how to apply it, all these problems become easy. I will see you for numbers, I don't know, 9 through 17 maybe we'll do next. Peace. See ya. Keep studying.